In this video, we are going to discuss about symmetric property of the DFT. First, we discuss the circular symmetries of a sequence. Then, we will see the symmetry property of the DFT. We know that N.point DFT of a finite duration sequence is similar to the N.point DFT of a periodic sequence. Here, periodic sequence is given by xp of n of period n. So xp of n is equal to summation m equal to minus infinity to infinity x of n minus m into capital N. If we shift this periodic sequence by k units, we will get another periodic sequence, that is xp dash of n, which is equal to xp of n shifted by k units. That is represented by summation m equal to minus infinity to infinity x of n minus k minus m into capital N. Here the periodic sequence is given, which is repeated. The same sequence is represented in a circular form. This x of 0, x of 1, x of 2 and x of 3 value, which is represented in anti-clockwise direction. It's also a periodic sequence which is shifted by 2 units when compared with the previous figure. Here this is x of 0, this x of 1, the values are shifted. The finite duration sequence is given by x dash of n, which is equal to the periodic sequence for the period of 0 to n, 0 for the other durations. Generally, the circular shift can be represented as the index modulo n. X dash of n is equal to x of n shifted by k modulo n, which is also written as x dash of n, which is equal to x of n minus k modulo n. The N.point sequence x of n is circularly even if it is symmetric about the point 0 on the circle. That is, if it is symmetric about x of 0, then x of capital N minus n will be equal to x of n. The N.point sequence x of n is circularly odd if it is antisymmetric about x of 0. In that case, x of capital N minus n is equal to minus x of n. Time reversal of an N.point sequence we can obtain by reversing the samples about the point 0 on the circles. That can be given by x of minus n modulo n, which is equal to x of capital N minus n. Time reversal is equivalent to plotting x of n in the clockwise direction on the circle. Till now we have learned about circular symmetries of a sequence. Now we will learn about symmetric properties of DFT. Assume the N.point sequence x of n and its DFT x of k are both complex valued. Then the sequence can be represented as x of n is equal to xr of n plus j into xa of n. This real part, this is imaginary part. Similarly, its DFT is given by x of k is equal to xr of k plus j into xa of k. This real part and this is imaginary part. For the sequence x of n, the DFT is given by x of k, which is equal to summation n equal to 0 to n minus 1 x of n into e power minus j 2 pi k n by n. The DFT is given by summation n equal to 0 to n minus 1. In the place of x of n, we are including real part and imaginary part. E power minus j 2 pi k n by n is represented as cos theta minus j sin theta. So cos 2 pi k n by n minus j sin 2 pi k n by n. Multiplying these terms, so the first term is xr of n into cos 2 pi k n by n. Second term is j into xi of n cos 2 pi k n by n. This term is xr of n minus j sin 2 pi k n by n. The next term is minus of j into j, that is j square. J square is minus 1. Minus 1 into minus becomes plus into xi of n sin 2 pi k n by n. Now we are going to separate the real part and imaginary parts. So the real part is equal to this cos term and this sin term, and the imaginary part we will get the next sin term and the cos term. Similarly, we can find the inverse DFT. We know the inverse DFT is given by x of n, which is equal to 1 by n into summation k is equal to 0 to n minus 1 x of k into e power j 2 pi kn by n. Instead of e power minus j, we'll get e power j 2 pi kn by n. So in that case, we'll get cos theta plus j sin theta. So similarly, if you are separating the real part and imaginary part, we will get xr of n and xi of n. For real and even sequences, if x of n is a real and even sequence, in that case, x of n is equal to x of capital N minus n. X of n is real and even. Xi of k is equal to 0. In that case, the DFT is equal to x of k. We will get only this cosine sequence. Similarly, IDFT also reduces to this term. So, we will get only the cosine sequence. Suppose x of n is real and odd sequences. Then x of n is equal to minus x of n minus n. XR of k, the real part of DFT, is changed to 0. In that case, the DFT reduces to this sine term. IDFT also reduces to sine term. If the sequence is purely imaginary sequence, in that case, x of n is equal to j into xi of n. In that case, xr of k will be equal to xi of n into sine 2 pi kn by n. Xi of k is equal to xi of n into cos 2 pi kn by n. Here, this xr of k is odd and xi of k is even. If xi of n is odd, then its DFT xi of k is equal to 0 and hence x of k is purely real. If xi of n is even, then xr of k is equal to 0. So, the DFT x of k is purely imaginary. These are the symmetric properties of DFT. For efficient computation of DFT, these symmetric properties are used. Thank you for watching this video.